Hello everybody, this video is going to cover a little bit of the connection between our chemistry topics and energy and waves and the math behind those. This is not stuff that we see often, but it pops up just enough that I want to make sure we have at least talked about it a little bit, that you're at least familiar with some of the terms and some of the equations. Make sure it's in your notebook somewhere for you to review. So first, one of the handy equations is to use the speed of light to help you do calculations involving the frequency of a wave and the wavelength. So they may give you speed of light and frequency and ask you to find the wavelength, right? As long as you have two of the three, you can just simply solve for your missing variable. One thing that they tend to do to be a little bit sneaky is instead of giving you hertz, which is the same as per seconds, they might give you megahertz. Or instead of meters, they might give you nanometers. They're trying to see if you can pay attention to your units and catch some metric conversions that you might have to do. Typically, we leave speed of light like this, meters per second, but you never know. Always double check your units. You probably learned in Honors Chem that we have a whole range of energy on our electromagnetic spectrum and that we can only see a tiny range. I'm not ever going to ask you, what are the, measurements for the visible range, but you should understand the concept that while there's lots and lots of wavelengths that exist, we may not be able to see them with our eyes other than this small little visible range here. Another handy equation is involving the energy, something called Planck's constant. That comes up a lot in chemistry if you take more chem in college. And then the frequency, which you saw on the previous slide. Here, one of the things they like to do is see if you can tell that joules is a derived unit. Joules actually is this crazy combo of units here. Kilograms, meters squared per second squared. They like to see if you can substitute and cancel your units out, things like that. Now, I know that people take their science classes in a variety of orders, but typically a lot of our students have not taken physics yet. And so for those of you who have not taken physics, I'm just going to show you a couple of things involving, the parts of a wave here. You can see we measure the wavelength from peak to peak. The crest is up at the top, the trough is down at the bottom. Amplitude is measuring like halfway from the wave to the top or halfway to the bottom. Just some terms that you might stumble across. Especially if you're doing any of the older AP problems, they did a little bit more of these before the redesign. Now, the relationship between wavelength, frequency, and energy, you probably learned about that in Honors Chem when you did the flame lab. You learned that a long wavelength has a low frequency, meaning that you're not going to, get a crest, a peak, very often, and there's low energy there. But if you have a short wavelength, the frequency is higher. You're going to get to that crest, to that peak more often. It comes more frequently and it has a higher energy. This next part has not really shown up very often, but I do think it's helpful just in case. The idea that waves can add together. And so if you have two waves that are in sync with each other, we call that in phase, we get what's called constructive interference, and so their energies will add together. But if your waves are out of sync, do you see how these don't line up? That's called out of phase. It's called destructive interference, and they will cancel each other out. Really, this topic is mostly about algebra skills and looking at your units Really, you're just rearranging some very simple equations to think about some complicated ideas, right? But the equations themselves are rather simplistic. And so to make these harder questions, they throw in things like those metric conversions. Now, sometimes you may have some slightly more complicated versions of these things. We have the de Broglie equation, which starts to add in the size of the particle, so the mass of the particle. And how does that affect the frequency wavelength? We have the Bohr equation, which is where this starts to come into the chemistry part a little bit more, relating this to the energy level that an electron would be in, where you have your nuclear charge and then the energy level that the electron is in. And then if you want to connect this to what you learned in honors chem, when you have electrons that are transitioning between energy levels, like during the flame lab, when they absorbed energy and then released it, you could use this version, which is finding the difference between where it started and where it ended up. And then if you have the energy, you could then go backwards and use your equation to help calculate things like the wavelength. And you could see what color light is being emitted during your flame test. So really, there's not a ton of new information here other than, a little bit of algebra. And then, when you do get a problem like this, pay attention and practice them and make sure you're thinking about it, since you don't see these very often. You're not going to get a ton of practice problems on them, so you want to make sure that you're really engaged with the ones that you do see. All right, that's it, everybody. I hope that was helpful. Bye.